Oops, sorry, I forgot to record earlier part of this, but I just started the recording. So we're doing point object, we need attribute and fields, and we have X coordinate and Y coordinate. That is correct. So we're going to do X coordinates. We can have X coordinate. I'm going to keep it simple and keep it, the data type for that would be integer. You could have a double, but I'm going to keep it simple and keep it integer, the whole numbers. We have X and we have int Y. Anything else that we need for attributes and fields, or would that be okay? So now, what's the first thing we need? I'm sorry, what's the next thing we need? Constructor, getters and setters to string, or does it matter which order we do that in? So how do you write the constructor? If I go back to the student class, the constructor is just a public method. You don't even actually have to write public keyword, but so public, and they actually have to have an object name in it. So in this one, we would need public point. So this would be a constructor. So there are two types of constructor. You can overload a constructor, or you can just have a default constructor. So we'll do both in this case. So this will make a default constructor. Default constructor is if they don't constructor. Yeah. So if they don't pass the value of X or Y to us, we can assign a default value. So default value for X and Y, we can just say set X to 0 and set Y to 0. That means the user is not defining any value for X and Y. We'll just set it ourselves. The next thing we can do is another constructor where we actually let the user decide what the X and Y value would be. So it would be public, point, same, and we actually have to overload it with parameters. That would be int new X, int new Y. That's what they're passing in. This will be used by the user to create an object of point. And now what happens inside the constructor? So there's one main thing that happens inside the constructor. What is that? Any guesses? So when I'm asking these questions during the lectures, there's not really, even if you have a wrong answer or anything like that, I'm not going to be like, that's wrong or anything like that. Just yell whatever you think is correct. It sets the values to the constants to be constants. So it actually sets the value to the fields. So it actually defines what the fields are supposed to be. So yeah, so you do, in this case, it'll be just assigning. So if you just look at the default constructor, what are we doing? We're assigning values to the fields. We're defining this object. We're just creating that object. We're assigning new values to these fields. So in this one, we're going to do X equals to new X, because that's what user is passing to us, and Y equals to new Y. So both of those two are constructors. This one is a default constructor. This one would be a constructor that we're overloading with parameters, and we're letting users define those parameters. So if you come in here, and now we have point P1, if I print the X, what would print? I defined a point object. I'm using the default constructor. This is where the constructor comes in. I'm not passing anything in. That means we're using the default one. And if I do P1.x, what value would be printed? 0, yes. So if I run it and it prints 0, why does it print 0? So I'm going to get rid of student. So the reason it's going in and getting 0, it's default value. So it's using the default constructor and getting this value right there. We can change this value to anything else, anything that we want. So let's say we want the default values to be 10 and 100. Now, if I run it, I get a value of 10. It goes in and checks what the default is. This is right now for this class, we're using the main method and we're designing the own object. But in reality, you'll be the one designing the object, and the user, someone else, will be using your object. So you get to decide what your object is going to do. So this one, these numbers depends on the project you're working on, or whatever program you're working on. You'll be setting these based off of that, these numbers. So now you have default. Now let's try to use the overload parameter constructor. So now we can do 2 and 5. So now we created a point object with the values that the user wants. The user wants the X to be 2 and Y to be 5. Now, if I run it, what would be printed? 2, because we actually defined it. We're not using the default constructor anymore. We're using this constructor right here. And now that new value comes in, 2 comes in here, it gets assigned, and X equals to 2. If I run it, all right, so now we got default constructor, another constructor. So you can have as many constructors as you want. So the only thing you got to make sure is the parameter range is different for each constructor. So one thing I cannot do is just copy this and have that again. This will give me a problem because I already have a constructor like this. I'm trying to add one more. That's not going to work. What I can do is do something like this. So I can only have one parameter, and I only ask the user for X, and I assign the Y. I can do something like this. Now I have 3, but this in this case would be useless at this point, but I'm just going to take that out. Okay. So what are the getters and setters? So getters and setters, or get methods and set methods. What are they? Public void set X. Yep. So that would be a setter. So oops, public void set X, and that would be int new X. And all you're doing is this dot X equals to X, new. So we actually haven't covered this keyword in this class. I think that it is covered in your reading, but we haven't actually used it. So this actually means this object. So whenever you refer to this, that means this object, and it actually goes in and get this X. So even if I go and change this to X and X, it knows the difference. So you see this is colored purple and this one is white. So because I have this dot X equals to X. So this all means this object. I'm talking about a value that exists in this file. Then remember, this value is coming from the user, so that value will not refer to as this. Only all the fields will be referred to as this. All the methods that we write will be referred to as this, but everything else that's coming from outside will not be referred to as this. So the more practice you do with this keyword, you'll understand it more better. But for right now, just remember so if you see this keyword, that means it's inside this file, inside this object. Okay. All right, so now we have set, and we can do set Y, and just copy and paste and just add Y and change the value Y everywhere else. It's like that. And same thing, what happens with getters? What are getters? So you should have setters and getters for each of your fields. So we have 2 fields, so we have 2 set methods. Now, if you want to write get methods, we need to do it for each of the fields. We only have 2 fields in this case. We would want to write that as well. So public int get, and all you're doing is returning the value of X. Copy this and get Y, and all you're doing is returning the value of Y. And the toString. How would you write a toString? So I'll write the header, what goes inside the toString method. So we have public string, we're going to return a string, and the method is called toString, and no parameters. And what actually toString does and what actually goes inside it. Any guesses? Does every object need to have a toString if it only deals with numbers? So this toString, you're right, not every object will need to have a toString method. But when you're testing it out and doing all that stuff, it's a good idea to have a toString method, even just for yourself. So you can actually see what the values are at that point. But yeah, you're right. Not every object will have a toString method. But in this one, it does make sense to have a toString method because we can print the point the way we want. So we can do is return something like this. So we can format the point to parentheses, X, comma, Y, parentheses. So when the user sees it, they see it as a format of a point. So we can do that, something like this. Parentheses, X, comma, Y, parentheses. So a string for representation of your object. Go back in here and I do just print it. I don't need the toString method anymore. I don't need to do p1.toString. It'll go in and call that. All right. So far we did two constructors, default with parameters. We have getters and setters. We have toStrings, toString method, and we have fields. Now we can set these to private and it still won't matter because we have getters and setters to access those. And we don't want user to access them directly. So the public keyword, even if I take that out, I actually don't need that because everything defaults to. So the next thing I want to talk about is, let's say you have one object right here. So this is considered an instance of an object. So this is an instance and object called. Now, if you can have multiple instances. So what you can do is you can have point p2 equals to new point, and we can have 5. So now they're both independent of each other. So this acts like a blueprint. So now, so you have a blueprint of point object, right? So this is point. We defined it. So you have a blueprint of point object, just like you have a blueprint of a building, right? So you have a blueprint of building. You can take that blueprint and you can have multiple buildings off of that. So let's say you have a blueprint of a house. There's never a case that there's only, well, there may be a case, but there's not likely that that blueprint is not used elsewhere. So you have a blueprint of point object. Now you can have multiple instances. So that would be P1, and then you have P2. So now P1 has their own X, their own Y. P2 has their own X and their own Y. So if I go and change, assign this to, what have we assigned? I think we assigned it P1 to 5, and then Y to 2. And here we have 2. And so X equals to, let's say, 4. And then we have 3. So go back here. So this is 3 and 4. And then we have 5 and 2. So now if I go and do p2.set x to, let's say, 10, what happens? What's the value of this right here? Does the value of this changes or does the value of this changes? Yeah, so this stays the same. So what does this 4 becomes? Or what does this 3 becomes? Where does 10 go? So the P2 would be, the X value would be changed to 10. So you understand when you create an object, you're creating a blueprint. So this right here is a blueprint of an object. You can have multiple instances. You can have thousands of them. You can have hundreds, even millions if you wanted to. Depends on the memory. So if you let's say you have an employee, right? Employee would be considered an object. How many employees you can have? All those attributes would stay the same for all the employees. So you have, if you create an object of employee, then you would have a name, their salary, you would have their ID and location and all that stuff. That would be an employee blueprint, an object, and you can have multiple of them. Just like a bank account, when bank account itself would be a blueprint object, then you can have multiple people can have that bank account, right? So that would consider an object. Same thing here. You have a point object, you can have multiple instances, P1 and P2. So if I run this right now, what would be printed? 5 and 2, because we haven't changed anything with P1. P1 would stay the same, 5 and 2. So what goes in the toString again? The toString is a string representation of your object. So this all depends on you. So however you want your object to be printed, you get to decide when you create an object. So it's just a string representation. Let me write that down. String representation of your object. So I had an example. Let's see. So let's actually do a bank account. So let's create an object of bank account, and we'll define fields and we'll add functions to it. Right. So far, we don't have any functions. Getters and setters are considered functions, but they're part of your object. But we will add some functionality to it. So we will add all this and a bunch more stuff. So how would you add a class? You just add a Java class, right click on source, and this time we're just going to do bank account. So in bank account, what fields do you think we would need? Remember, we need fields, we need constructor. It's just a good habit of adding all those things in as soon as you define your object, and you need toString. And then if you wanted to add something else, we could. So what fields would go into bank account? So think about real world. When you go to your bank, what could be in there? Balance, we need balance. So balance could be a double. So double kind of makes sense because you could have cents in there. So double, like account numbers. Yeah, so we could need account numbers. So we would need double, and we need account numbers. So that would be, let's say, instead of account numbers, let's do account numbers. Yeah. So we'll do int account like this, right? We need account number, and I'm actually going to move this up. Account number. And what else? Yeah, so you get a bunch of fields in there. So I'll go ahead and add the name in there. So you add string, and you have the name and client's name. Or one thing I do want to add would be, let's add transactions. So how many transactions they have. And let's do transactions. Something like this. So you have account number, balance, name, and now we have constructors. The default constructor, should we have a default constructor? Can you have an account with no information in it, and bank lets you create an account with no information? They need all that information to create an account, right? So we're not going to have a default one. Start with zero balance. Yeah, so we could have, wouldn't be a default. So default constructor usually means you have no parameters coming in. You actually have to have a name and an account number to get started, right? So in this case, what we'll do is we'll do bank account. And in this case, the things we actually need to get started would be account, okay, not even account number, the name, string, name, new name. So we can call this a default constructor. The only thing we need to get started is a name. Everything else we can just assign on the fly. So what we can do is account number. Well, can we have account number? We could have some kind of mechanism that generates the account number, random generator. But even in that case, you can have duplicate account number. You don't want to have duplicate account number. So in that case, we'll just, for this example, we'll just have the user enter the account number. You have account number coming in, and that account number, I'm going to call that new, something like this. And then you have a name equals to new name. And the balance and transactions, we can set those to default. So the balance equals to 0. We can have a start with the 0 balance. And then as soon as they deposit the money, that's how it works. Even in real life, when you open an account, there's there's never a case you have a balance of $100. You always open an account, then you deposit. So we'll just keep that as it is. And transactions, how many transactions the user had. If they just open an account, it'll be just 0 transactions. If you want, we can add more constructors, different types of constructors. For this example, I'll just keep it simple and leave it. We need getters and setters, and getters and setters will have public set. In this case, do we want to have setters? Do we want user to set any of our fields after they open an account? So in this case, I don't think we want setters, because the account number is assigned once they open the account. The name is set, and then the balance, the balance would be updated when they deposit. So we can have a function that calls deposit. So we can add a function that does deposit, and we can add a function that does the transactions. We don't want user to updating this, so we don't want to see setters at all. So we could have getters for all of them. We can give the information if they want to see something. So we can do public, and the first one would be int get account number. We'll just do return this dot account number. Then we have public string get name and return this dot name. And we need public. We have int get transactions. We'll do return this, and we have public. And the last thing we have is the balance. And the balance is double return this dot balance. We have a toString method, just like this. And remember, this is a string representation of your object. So our object is bank account. We get to decide how we want to display that account. So we can create a string. So we have string account equals 2, and we get to create however we want it to display. So first thing, let's say we want to do is account number, and then we have then account number, just like this. Then we want to do is name, so new line, name, and it'll be just try to get a habit of using this keyword. And then we have name, and last thing I wanted to display is balance. This dot have account number, we get the account number, the name, the balance, and the last thing we need to do is return account. All right, so we have wrote a lot of code, but we haven't actually tested anything yet. So let's go and test that out. So I'm going to close the point object and get rid of this. And now I'm going to create bank account for, let's say I'm creating for account 1 equals 2, new bank account, and I'm going to pass in, let's say if it's actually giving me an option to see what I can pass in. It's not giving me an option, so I can go look at the constructor. And there's one problem here. Oh, right there. Never mind. So I need to provide account number and the name. So account number I can give, hey, that's the first account, and I can just give my name. Now if I do system.out.println and I print account 1, this is what happens when you work with a lot of different languages, you just forget. All right. So now run it again. All right, so account number is 1, name is Usman, and balance is 0. So whatever we have done so far in bank account, I just wanted to test it out. It's working. Most of it is working. We're able to create an account, construct it, and print it. We haven't actually tested these get functions, but I'm pretty sure they're simple enough that would work. So next thing I want to add is the deposit. How would you write a deposit function? The user will be able to deposit Scanner the user for, so remember we're using main function to talk to the user. So whenever I go into main, I'll become a user. And whenever I'm in bank account, I become like a programmer. So we can use the main function to test it out. But in here, how would we add a public deposit double amount? So it would be public void deposit. So we could have a scanner to ask the user how much they want to deposit. Yep, you could do that. But for this one, we'll just keep it simple. We'll just do a deposit function, and there'll be double and amount. So now this will be added to where? So what happens inside the deposit function? Updates the balance. So the amount that's coming in will be added to the balance. So it'll be, let's say, let's do this. The balance, the start balance plus equal. Is there anybody who does not know what this means? Plus equals. If you're in 219, I think everybody knows, but this is the same as the start balance because we don't want to lose the old balance. We want to add it to that balance and then set it back. So now we can test it out here. So now the balance is 0. We're going to add deposit something. So we do account one dot deposit, and we're going to deposit $50. And nothing happens because I'm actually not printing account one after the deposit. So let's run it again. So I had a balance of 0, and then I did a deposit. I have a balance of 50. So in real life, what actually happens is you have this object right here, then you have this main class, and then you actually have another one that's the GUI, the graphical user interface, the one that they actually use, or the ATM, when you go into press the deposit key, the button. What happens is they run this code in the background. So account one dot deposit 50, they get added to the object that's been created. So when you move on to using GUI and all that stuff, you'll learn how to interact with your main and how would you be calling these functions inside that that button. So as that button is pressed, this line of code is run, and that $50 is deposited here. So we have the balance. One thing we forgot to do when we did the deposit is, remember we have this transactions keyword. This transaction keeps track of how many transactions the user has had. We haven't updated that. So what should we do in here? So deposit is a transaction. What should we do with transaction? Add one to the transaction. So we have this transactions, and we do this plus plus. That's the same thing. Now, if I look at transactions, we have system. So I always tell students that the programmers are lazy, very, very lazy. And that is 100% correct. If you're able to use the old code, why write the new one? So you'll see me copying, pasting all the time. But that's how actually everybody does it. So we'll do get transactions to get what transactions are. I'm going to use this same code again to get the transaction to see if it was updated. So if I run it, I have a balance of 0, transactions is 0. Then I have a balance of 50, transactions move to 1. So what transactions does is, remember, every time you go to the bank, there's a transaction happening, right? So the transaction keyword or the field here keeps track of how many deposits and how many withdrawals have you had in your account. So when you do a deposit, all I'm doing is adding 1 to transactions. So if plus plus doesn't work, we can do equal this transactions plus 1. So this would be the same thing, adding 1 to the transactions. And what happens here is I'm just printing it out what the transactions is for your account before I do any transactions. So remember, deposit is a transaction. So I'm just testing it out right here. This will represent right here. And this will represent this line right here. We can have a deposit. We can also have a withdraw. How would withdraw work? So we have public void withdraw, and withdraw would also take the amount, how many how much you're trying to remove. But there's a trick here to withdraw, right? So what is that trick and how would you actually write that? So how would you actually write withdraw function? What goes inside that function? So you would have, so it's gonna copy your line of code. So you have Miguel, so you do this dot balance minus equals to amount. So this is where as a bank or as a programmer, you would have to actually decide, can you have negative balances? Are you allowing users to have negative balances? So let's say they have $50. Can you allowing them to withdraw $1,000? Then they would have a negative balance of -50, a negative 950. Do you want the user to do that? Because right now I don't have any restrictions on doing that. So if I go back, I'm going to get rid of transactions for a minute. So you have account, I'm printing account, I deposit it, I print account again, and then I do account one dot withdraw, and I do 1,000, and then I'm printing the account one more time. So now, started with this zero balance, then we have deposit of 50, and then we did a withdraw, and we have a negative 950. If you're working for a bank that lets you do that, that's great. We don't need to change anything. We can leave it as it is. But most of the banks don't allow you to do that. So here we need to set a check in here. So the amount that they're withdrawing, does that person even have that much in the account? And how can we add that? Is the restriction using the if else? Yes. Yes. To use the if statement to check for that condition. And what would be the condition? So you have if, how would you check if the user has enough money to withdraw? Amount is greater than or equals to 0. So and if you have that condition greater than 0, then you're only checking if the user has something in the account and they're still able to withdraw $1,000. But you want to check the amount that's coming in against the balance. So it would be, if they have enough, would be something like this. Yeah, you go. And then to do less than, yeah. So it would be something like this. So balance, copy the comments or the chat. So you have balance, this dot balance is greater than or equals to the amount. The amount they're trying to withdraw is less than or equals to the balance. We'll go ahead and let them withdraw it. Else, we can give them a message, system.out.println, and we'll just tell them you do not have sufficient funds in your account. Now, does that make sense? So the balance has to be greater than the amount they're withdrawing. If that's the case, yeah, go ahead and do whatever you're trying to do. Else, we're just going to give them the message, no, that's not possible. So if we go back and stick with the same example, we have account one. I'm just going to comment this one out too. So run it. We have 50. Then we try to withdraw it right there. I got a message, you do not have sufficient funds. And I check the balance afterwards on line 15. I get a balance of 50 because nothing